So we are going to continue on with methods of building up continuous functions. So here we want to actually build continuous functions. So that's going to be take some basic functions and look at combinations of functions that make continuous functions. So first thing that we get is basic laws of continuity. So we're going to assume f of x and g of x are continuous at x equals c. So let f of x and g of x be continuous at x equals c. Then if that happens, the following functions are also continuous at x equals c. So we have, if you have the addition of two continuous functions and the two base functions are continuous, then if you add them together, that's continuous. And if you subtract them, that is also continuous. Second thing, if we multiply by a constant, k times f of x, that will be a continuous function. Third thing, any product. So if f is continuous at c, g is continuous at c, then f of x times g of x will also be continuous at c. And the fourth thing is the division, as long as the one in the bottom is not 0 at c. So g of c cannot equal 0 because we don't want division by 0. So if you have two continuous functions at c, you can add them together and make a third continuous function, or you can subtract them. Can multiply the function by a number, can multiply the function by the other function, or you can divide them as long as the bottom of the division does not equal 0. Those will all generate continuous functions. Next up, we need to talk about polynomials and rational functions. So we're going to let p of x and q of x be polynomials. So p of x and q of x are polynomials. Then p of x is continuous on the real line. So what that means is any polynomial is continuous for all real numbers. And we get p of x divided by q of x. So polynomial divided by another polynomial. That's what we consider a rational function. This is continuous on its domain. That basically means you need all its domain's all numbers where you don't get division by 0. So as long as division by 0 isn't happening, then the p of x over q of x, polynomial divided by polynomial, which is a rational function, is also continuous. We're going to talk about continuity of some basic functions. So we get that y equals x to the 1 over n is continuous on its domain. For n a natural number. Y equals sine of x and y equals cosine of x. These are continuous on the real number line. On, we could just say the real line, I guess. So it's continuous for all real numbers. y equals b to the x power, so that's our exponential functions, are continuous for b is greater than 0 and not equal to 1. And then our logarithms, log base b of x, these are continuous for the for x needs to be positive, b needs to be greater than 0, and b cannot equal 1. So basically 1 over n, as long as the n is a positive whole number, meaning it's natural, that's continuous. Sine and cosine are continuous. B to the x is continuous as long as the base is positive and not 1. And log base b of x is continuous for positive x's, as long as the base is bigger than 0 and not equal to 1. Furthermore, we get continuity of inverses. So we're going to say if f of x is continuous on an interval I with range R, and if the inverse function exists, then f inverse of x is continuous with domain R. And that has to do with the range of the base function is the domain of the inverse from algebra 2. All right, last one of these building function types that we're going to write out is going to be composite functions. Then we're going to talk about a elementary function and go from there. So we're going to say if G is continuous at x equals c, and if, and f is continuous at x equals g of c, then the composite function f of x equals f of g of x is continuous at x equals c. So if you have a function that is continuous at a point, and you have another function that is continuous at the output of the first function for that point, then the function that's formed from the composition is continuous at the point as well. The last thing is an elementary function. This is a function that is constructed out of the basic functions. So this is constructed from basic functions and combinations, or you could say and operations of addition, subtraction, multiplication, division, composition. And since the basic functions are continuous on their domains, an elementary function will be continuous on its domain. So since the basic functions are continuous on their domain, Any function you can construct from the basic functions in these operations, an elementary function is continuous on its domain. So for example, if we said f of x equals, like, let's say cosine of x squared plus 2 to the x minus sine of x cubed plus 2, all that divided by, I don't know, x minus 8. This is continuous on its domain, which would be the set of all x such that x is a real number and x is not equal to 8. So basically, if you recognize something is formed from these operations of basic functions, that tells you some information about where it might be continuous, and that's based on the basic functions themselves are continuous.